I'm Lamar, and this is the first episode of I Think I Know Stuff. In the first episode of I Think I Know Stuff, we're going to go ahead and cover the explanation of what NAT or PAT is and the different types of NAT and how to go ahead and implement it there in your Cisco router just to go ahead and put it on your home network or your enterprise network. Wherever you want to put it at, you'll go ahead and have a better understanding of NAT.
Okay, so as I stated earlier, I'm going to go ahead and explain what NAT is, the different types of NAT, and why I chose overload NAT, or which is also known as PAT, as my choice. So basically, when they created NAT, it was put in place to preserve the amount of IP address because IPv4 only had so many addresses in the world, had way more devices just to go ahead and take up that IP range. And the first type of NAT is static NAT, which is a one-to-one translation, meaning that if we had 3 hosts on our LAN and we only had one public address versus these 3 private addresses, only one at a time can take this public address and ride out to the internet. So it's only one connection per IP address. Everybody else will have to wait their turn. That is very cumbersome. It will bottleneck the network as far as internet access. So after static NAT, they created dynamic NAT. And with dynamic NAT, it's a little bit better. Now we have a pool of public IP address, and everyone can take one IP address from this pool here. So that means if we only had 3 users and 3 public IP address, each one can access the internet and go on out the organization at the same time. But then that still required each company or each person or whoever had multiple devices that need to get to the internet to buy multiple public address. To save money as well as reserve space in a better way, they came out with NAT overload or PAT. So network address translation overload allows you, pretty much like dynamic NAT, to go ahead and reserve these IP addresses, but we do more of what a static NAT does with one IP address. And the way these 3 users are able to do that at the same time is because they use the same IP address with a different port number. And this isn't any specific order or any type of any specific numbers or whatever. This is just however the router. This is just an example of how the router grabs a or creates a port number and assigns it to each connection. All right, now I'm glad I got the explanation of each one out of the way. I'll go ahead and show you how to properly implement NAT overload. Okay, so now we're here in the router. I'm going to go ahead and go through a couple of steps that we need just to implement PAT. And just to begin, we're going to need basically a pool of IP of our public address, but unlike dynamic NAT, we're not going to have an actual pool. It'll be a pool with only one IP address in it. Let's go ahead and get to config terminal just to get there, and we're going to go IP NAT pool, and we can call it whatever. Let's go home net. That's what we're going to call our pool, and we're going to give it our WAN IP address. So go 172.17.1.1, and it's going to expect another IP address, so we'll go ahead and put in the same thing. And from there, we're going to enter the net mask, or 255.255.255.252, and then we go ahead and hit enter. First step. Second step, go ahead and do the IPNet inside source list. Net inside source list. You can go list 1, and we're going to tell it what pool to use. And that's how we're going to type it, the same way we put up there, home net. And we're going to make sure, this is the most important part, go ahead and hit overload. Hit enter. Now, after that, we're going to have to go ahead and tell it which port to NAT inside and which port to NAT outside. And the port that we're going to NAT outside is going to be our WAN interface. I'm sorry, let's get to our WAN interface, which is interface FA0, boom, IP NAT outside. And then we're going to do our LAN with IP NAT inside. LAN interface is 1.0. Just up arrow that, change outside to inside. Inside. Boom, now it knows where we're natting. And we can exit out of the interface and set up the access list. Access list 1. We're going to permit anything from our LAN subnet, which I have set at 167. Fat fingered that. 78.9.0. And instead of a subnet mask, we're going to do what's called a wildcard mask. And that's going to be every octet flipped, or should I say, you can take every octet of the subnet mask and subtract 255, and that's what we're going to have there. So 0.0.0.255, since that's a slash or side of 24. Enter. And now our NAT works. Or should I say it works? We're going to go ahead and test it out here in a sec. Alright, so just to go ahead and test and make sure that configuration works, I threw a couple of test items here, which would be this desktop, this switch, which has nothing on it, and this test router for our WAN connection. And I went ahead and pinged across, made sure I can get to the gateway, make sure I can get to our WAN connection, and then I went ahead and pinged all the way across to the other end of that WAN connection, just so we can see that NAT translation. And I'll go ahead and cut over to the router so I can show you guys how to check that out and see that we are having network access translation. Okay, I was a little bit jumpy there, rushing the process. I guess I couldn't get my translation to show up really fast. This is just a simulator. After going ahead and pinging all the way across our WAN connection, we got our NAT access, our NAT or network access translation chart here. We can check and see our translations, which show IP NAT. There's a couple of other commands that you can input, like debug IP NAT or clear IP NAT translation, just in case you want to clear up anything old and see what else you're getting translated. But there you go, your NAT translation and how to check and make sure you're having your translation come through.